Okay, I'm going to go through the 2 or 3 problems that are on the exam this year that weren't on the exam last year due to us not doing the project that was done last year. So number 8 is a rational functions graphing problem. So remember that the standard form for the rational function is this is this is k, this is minus h, and this is m, or a, okay? So, like, if you look at this, minus h is negative 2, or minus h is 2, so that means that h equals negative 2, right? And you could also do it by comparing it to the standard form here. I'm going to write it out here. Okay, so if you look at this and you look at the original, you're going to see the minus h is plus 2 and plus k is minus 1, right? So where is the center of this function? The center of the function is going to be at negative 2, comma, positive, or negative 1, right? Okay, so first thing we're going to do, we're going to fill in the xy table for the parent function. And remember, the parent function, you just make the h and the k 0, that would be the parent function. So the parent function is y equals 3 over x. So let's do y equals 3 over x in the xy table here. So the parent function would be x equals 3 would give me 3 over 3, which is 1. X equals 1 would give me 3 over 1, which is 3. X equals negative 1 would give me 3 over negative 1, which is negative 3. And if I put in negative 3, it would be 3 over negative 3, which would be negative 1. And if I put in 0, I would get infinity, which would be the vertical asymptote position, right? So just like illegal value. Okay, so let's first graph the vertical asymptote, which we know is at x equals 0, for the parent function. And then we'll graph the horizontal asymptote for the parent function. We also know that that is y equals 0. And then let's do the points that we wrote down in the xy table, 3, 1, 1, 3, negative 1, negative 3, and negative 3, negative 1. And then we're going to graph it using the aid of our asymptotes, right? So the asymptotes, we know that we're not supposed to cross those asymptotes, so we're just going to come close, right? Now we're going to use the h and k translations to draw the rest of it. Oh, by the way, the rest of these here, we can just like do while you're graphing, before you're graphing, or after you're graphing, whichever you're more comfortable with. I think it's easier to graph it first, so I'm going to graph it first. So the real function, what I'm going to do is I'm going to take each one of the points that I graphed and the asymptotes that I graphed, and I'm going to move them 2 to the left and 1 down. 2 to the left and 1 down, because h is negative 2 and k is negative 1. So 2 to the left and 1 down. So each one of these points, I'm going to move 2 to the left and 1 down. So like this point here, do you see how it moved 2 to the left and 1 down? And then this one here, 2 to the left and 1 down. Okay. And then this one here, 2 to the left and 1 down. And this one here, 2 to the left and 1 down. So I moved all my points 2 to the left and 1 down. Now what I'm going to do is I'm going to move my asymptote 2 to the left and 1 down. So I'm going to make a little thinner line than I did before. So if I move the blue line 2 to the left, it would be here, right? If I move the horizontal blue line 2 left and 1 down, basically I'm just moving it 1 down, so I move it 1 down, right? If I move a horizontal line to the left, you can't really tell, right? If I move a vertical line up and down, like down 1, you can't tell. That's why the vertical line, the vertical red line is the blue line moved over 2 to the left, but it's not really moved down because you can't move a line down. Okay? And the horizontal red line is the blue line moved down by 1, but we didn't really move it to the left by 2 because you can't really tell. Okay? Now we're going to use the guide of the asymptotes to help us draw the red function, which is the translated function. Okay, and now it asks us, find the vertical asymptote equation. Looks like our vertical asymptote is at x equals -2. It crosses x equals -2, right? So the equation is x equals -2, and make sure you have the left side of it x equals. That is, you need that for full credit. Find the horizontal asymptote equation. The horizontal asymptote crosses the y-axis at -1, so it's y equals -1. Make sure you have the y equals there to show that it's a horizontal asymptote. Write down the domain and range in mathematical notation. Well, the domain is the opposite of the vertical asymptote. So if I say x equals -2 for the vertical asymptote, I'm going to say x is not equals -2 for the domain. And for the range, I'm going to say the opposite of the horizontal asymptote, which is going to be y is not equal to -1. That was easy, wasn't it? Now I graphed. It says to graph 3 points per side. So if you want to graph a third point, what you can do is you can put in like a point like 2 and -2 for x. So if I put 2 in for x, I get 3 over 2 for y, which is 1.5. If I put -2 in there, it would be -3 over 2, which would be -1.5. So that would give me 2 more points to make my graph even better. So I'm going to put 2, 1.5, which would be 2, 1.5, I'm going to graph it in blue first. 2, 1.5, it would be right there, right? And then if I were to translate that 2 to the left and 1 down, it would be exactly here. So you can see that I can improve my graph a little bit by making it go down a little bit. And then if I was going to do a second point here, the second blue point on the left side, it would be -2, -1.5. Ooh, I did a pretty good job on that one. And then if I were to move that point to the left and 1 down, it would be right there. So you can see that I can improve my translated graph a little bit because really it's going through there. Okay? All right, and that is number 8. Let's go to number 9. The graph shows a hyperbola. Write its equation in standard form. Okay, so first thing you want to do when you're graphing or finding the equation for a hyperbola is to figure out where the box is. And what I mean by the box, I mean the box that goes between the two vertices. First thing you do is you draw a horizontal line out from this vertex until you hit the asymptote, and then you turn down until you hit the asymptote again, then you turn right, and notice that it crosses the other vertex. Perfect. Then you know you're right. Hits the vertex, turn again. Hit the vertex, turn again, and we've made the rectangle. Okay? Now in this particular case, this rectangle happens to be a square, but so what is the distance from the center to each one of the sides of the square? So going in this direction, I can see I go 3 units. So of course, going in this direction, I also go 3 units, right? Going down, I go 3 units. So that means going up, I also go 3 units, correct? Okay. And where is the center here? The center of where the asymptotes crossed is at 3, -3, okay? Guess what? This happens to be your h and k values that you're going to use to write your equation, okay? What about the horizontal 3 and the vertical 3? The horizontal 3 is your a value, and your vertical 3 is your b value. And we'll plug these into the standard form so you can see where they go, okay? So let's see. The standard form for a hyperbola is either x squared divided by a squared minus y squared divided by b squared equals 1, or y squared divided by b squared minus x squared divided by a squared equals 1. How do I know which one this is? Well, this is an up-down hyperbola and not a left-right hyperbola. The up-down hyperbola is this standard form, and the side-to-side hyperbola, the left-right hyperbola, is this one. Okay, so this one is like this, and this one is like this, and that's how we know which is which. Okay, last thing. The standard forms here don't show any translations, but we want a translation. In this case, we're doing the up-down one, so I'm going to show you how to translate this one. Remember that k is always associated with the y, so I'm going to subtract it here. X is associated with h, so I'm going to subtract it here. Okay, so that is the standard form. Now I'm just going to plug in my a value, my b value, my h value, and my k value, and I'm all done. So I'm going to do that up here. So my y, I don't plug in anything for y, of course, because we need the y in there to be the equation of a curve. We're going to put k, which is -3 squared, divided by b squared, which happens to be 9, right? But I'm just going to write b squared. And then on the top, I'm going to put x minus, and my h value is 3, and my a value is also 3 squared, right? I could put 9 if I want to, equals 1. I always need to put the right side. That's totally necessary. Okay? So that's it. If I want to simplify it and I want to put, like, instead of minus -3, I could put +3 also. Number 10. Okay, remember whenever you do these that we do want to complete it by doing a check to show that the values are correct. If you do it that way, then you don't need to worry so much about the illegal values. But let's see, what are the illegal values? Well, I got z in the denominator, so that means z cannot be 0, okay? And I got z minus 3 in the denominator, which means z minus 3 cannot be 0. If z minus 3 cannot be 0, that means that z cannot be 3. So the two illegal values are z cannot be 0 and z cannot be 3. Let's cross multiply so that we can solve this, okay? So I would have 4z times z minus 3 equals 8z. Then I'm going to expand. 4z squared minus 12z equals 8z. Now I'm going to try to put everything on the left side and leave 0 on the right side. I'm going to subtract 8z from both sides. And then I'll have 4z squared minus 20z equals 0. Now I'm going to try to figure out what values of z make this true. The first thing to do is to factor. 4z minus 20 and z. I factored it into those two. And now I can figure out, okay, now I can use the zero factor property, which is, okay, what values would make these two numbers multiply times each other, this number and this number, these two numbers multiply times each other get 0. So it's either that the left number is 0 or the right number is 0. If the left number is 0, basically that's saying that z equals 0. So that is one of our possible solutions. The other possible solution is 4z minus 20 is 0. 4z minus 20 equals 0. So that means that 4z equals 20, which means that z equals, divide both sides by 4, 5. Okay? So that is the other possible value of z. So it could be 0 or z equals 5. And now what we're going to do is we're going to put 0 and 5 back in the original equation to see if it works. And when we do, we'll notice that, oh, if I put 0 in the left side, do you see how I'm going to get 0 divided by 0? That's illegal. Okay? So we do not want to use the solution z equals 0. It doesn't work, right? If I put 0 in it, I'll get 0 divided by 0 equals 1 over -3, and that's not true. Okay? I can also try z equals 5. If I try z equals 5, I get 4 times 5 divided by 8 times 5 equals 1 over 5 minus 3, which is 2. Now, that would give me 1/2 equals 1/2, which works. Okay, so the solution in this case is just z equals 5. Z equals 0, we eliminated the solution.